Okay, so as you go through, we want to probably isolate. We said this is not the way you have to do it, but foiling or like squaring both sides. When you foil the left-hand side, that's going to be pretty complicated when you square that. So we said if we can isolate it and then just square the term that I have boxed, it would look better than squaring this whole big quantity right here. Because you have to take it times itself. It just doesn't get rid of the square root signs. So we want to move this y, the square root of y, over to the other side. So you're going to get the square root of y minus 27 is equal to 9 minus the square root of y. Now on the left-hand side, I can get rid of the radical by squaring it. If you square one side, you have to square the other side. So the square root and the square root and the square cancel each other over here on the left-hand side of the equation. So that means you are left with the radicand value, which is y minus 27, because you're taking the square root of y minus 27 times the square root of y minus 27. That radicand value is the same, then your root is gone. On the right-hand side, what you have to do is if you are squaring it, it means that you take it times itself. So you have to FOIL. If you multiply the first together, you get 81. If you multiply the outer together, you get negative 9 radical y. If you multiply the inner together, that negative sign, you're still going to get negative 9 radical y. And if you multiply the last together, careful, you have a negative times a negative, which is a positive. Radical y times radical y is just y. So I'm going to, we went through this yesterday, we kind of combined two steps. If I subtract y from both sides, they cancel. So you get negative 27 is equal to 81, and I'm going to group these two terms together to give you negative 18 radical y. What's the next step you do? Bring the 81 over. So I want to subtract 81. So you get negative 108 is equal to negative 18 the square root of y. The next thing? Negative. Divide by negative 18. Oh, you might have moved the opposite ways. I don't know. So anyway, you get 108 divided by 18 is 6. So now you get 6 is equal to the square root of y. And how do I get rid of the root again? You square it. So I square the other side and you get 36 is equal to y. So if you check yourself and you put 36 in for y, 36 minus 27 is 9. And if you take the square root of 9, you get 3 plus the square root of 36, which is 6. And 3 plus 6 does equal 9. So that's what we talked about yesterday. There are examples. We went through plenty of examples yesterday. This is one that we worked through. We went through plenty of examples, and we also talked about fractional equations, which I did not leave as a bell ringer today. But keep those in mind as well. The video is posted. So the next thing that we want to look at today, good luck today, by the way. Nervous?
I'm very nervous. I've been up since 5 a.m.
And where's Lathan?
Yeah, it sucks. Because he was supposed to get, there was these 2 neighbor runners, and he was supposed to get, that would have got us, saved us about 4 or 5 points, which would have got us over the lead over Maywood to win the third, but yeah.
He's been sick.
Yeah, I know, yeah.
Okay, we look at this. Yesterday our bell ringer was elimination substitution problem. It's leading us up to this today. I told you yesterday it lead us up to this. And this happens to be with 3 variables though, but you still do elimination substitution. Now there's multiple ways you can solve this. So what I don't want you to think that, oh, I have to do this step, and then I got to do this step, and then I got to do this step. So instead, I want you to tell me something you think you could do to this, and I'll tell you if it's a correct step or not. Trista.
Well, some form of something to the bottom. The middle one, well, let's say is 0, and the top one is 3.
Or can you just move the x, move the 2y over, the x equals positive 2y, and then substitute the 2y in for x?
You can do substitution. Let me back up. When you solve for a system of equations, you have 3 unknown values right now. You need at least 3 equations to solve. You need the same number of equations, at least the same number of equations as your unknown values. One method that I heard that I would agree with, because what you want to do is work with one equation, meaning I could take the bottom one and I could say x is equal to 2y. That's one thing I heard. If you were to do that, now you want to substitute and put a 2y here and a 2y there. When you do that, that's going to leave the top equation in terms of y and z, and the second equation will be in terms of y and z. Because when I put 2y in for x in the top equation, it becomes 4y plus 2y. Then you get an equation that looks like this: 6y minus z equals 14. And if I put 2y in for x in the second equation, 2y times 3 is 6x plus 3y is 9y plus z equals 16. If you do that, then what can you do? Then you can just do elimination. But the third equation, I manipulated that and rewrote it as x is equal to 2y. So I am substituting the rearranging of that third equation into the other 2 equations. You could. You could. And as you look at this, then you could solve and you would get 15y is equal to 30. 15y is equal to 30. So divide by 15 and y is equal to 2. You could do that. Then you put it in right here, and what do you find out? X is what? 4. And then you put those in for x or y in one of the top 2 equations and find z. That is one thing you could do.
You just like forget about your third equation.
The third one you work with first. The third one, the third equation you work with first, and you get this right here. X equals 2y. So that's where you substitute into the other 2 equations. No. X minus 2y equals 0. I'm going to add 2y to both sides, and you get x equals 2y.
Is there always going to be like
Substitute into the other 2.
Is there always going to be
There is not always just something where you can say what is x equal to, what is y equal to, what is z equal to, and you're only going to have one variable. So you come back to this equation and something else you could do. Let me see how I want to do this. Do I want to erase all the green and show you another method? Or do I leave that and try to copy and paste this over? Trying to decide the best way to do it. Let's see what happens here. Oh, no way. Here we go. So coming back to this problem right here, here's what happens. We found out what y is, right? We found out what y is equal to. We found out what x is equal to. And now I could put it into one of the two equations. If I put it in the top equation, if x is 4, you get 4 times 2, which is 8. If y is 2, you get plus 4 minus z equals 14. So this becomes 12, and if you subtract it, you get negative z equals negative 2. No, equals positive 2, because you subtract your 12 here. And then you divide, and you find out that z is equal to negative 2. So you would have three values. It should make every single equation true. We said it's an intersection point of 3 lines yesterday, because we said you have the xy axis, and where's z axis? Coming out towards you. So the z axis is coming out towards you, and you're going to go right or left, up or down, and then you're going to go forward or backwards. And you got these lines going up. You're not going to have it on paper. You would have to get into some 3-dimensional drawings. So you look at this. X is 4. It should make every single equation true. 4 minus 2 times y, which is 2, that does equal 0. You look at the second equation. It's going to be 3 times 4, which is 12, plus 3 times y, which is 2. There's 6. That's 18. Now, 3 times x is 4. 3 times y, which is 2, 12, 6, oh yeah, plus z, which is negative 2. So you get 12 plus 6 is 18, plus negative 2 is 16. That's a true equation. So all 3 of those make it true. But here's the other thing you can do. You can work with just 2 equations at a time. Elimination, substitution. This just continues. Elimination, substitution, elimination, substitution. If you don't like solving for one and substituting that value into the other 2 equations, pick 2 equations and do elimination. What do you notice about these top 2 equations? What do you notice about the z's? The z's already cancel out. So if I take those top 2 equations, 2x plus 2y minus z equals 14, and I take the second equation of 3x plus 3y plus z equals 16, and if I group those together, the z's cancel, and you end up with what? 5x plus 5y equals 30. Now you can use that equation. What's an equivalent equation to that? What if I divide both sides by 5? What do you get? X plus y is equal to 6. You could do that. You have smaller numbers. That's okay. But if you choose not to do that and you just take this that you found, you want to take that equation that you got and you have one more equation that you did not work with. What's the equation you did not work with? The bottom one. So I'm going to take that equation and stick it underneath there, and that should look like a familiar type of problem. Because what would you do to solve that? Elimination, substitution. I'm guessing you would take the bottom one times negative 5. So you're going to get 5x plus 5y equals 30. The bottom becomes negative 5x plus 10y equals what? 0. The x's cancel. You get 15y is equal to 30. So y is equal to 2. Is that what we found out through the substitution that Landon asked if we could do? Yeah.
Wait, can you go back to it? So when you have the 2x plus 2y equals 14 at the bottom equation, can you just like do times like could you do substitution on that without doing like using
Put like the x equals 2y every time.
oh like yeah on the first equation could you just do substitution on that instead of just
You can, but let me show you if you choose to take this top one right here, what are you going to solve for? Ooh, okay, I'll show you. If you want to solve this equation like for x and then substitute, if you were to do that, you're going to get 2x is equal to 14 minus 2y plus z, and then you divide everything by 2, and what you're actually substituting in then is you're going to say x is equal to 7 minus y plus 1/2 z. You can do that if you want to work with substituting something like that in. But the thing is when you substitute that in, you're going to have equations with y and z. So it's not like it's just going to solve a value for you. Because even when you substitute that in right here, you're putting in right here, you're putting 7 minus y plus 1/2 z. Oh, got my z's and my 2's. So you're putting in 7 minus y plus 1/2 z, and then you get minus 2y equals 0. Does that look easy? If anything, I would have probably solved for z in either one of the equations because you'd have whole numbers, not fractions. But if you're looking for the easiest route, Landon's way of solving for x right here was probably a good way. Because then when you substitute it into the top two equations here, you have two variables, elimination, substitution, something that you're used to. If not, you work with two equations and you use the result of that with the other equation that you did not use before. Now this one, you would continue with this. We just got y is equal to 2. Where would you go from there? I would substitute it back in, probably into this equation right here. And if you do that, you're going to get x minus 2 times 2 equals 0. So x is equal to 4. That's what we got before. And then you're back to that last step we did on the last problem. So we look at something like this. You have x, y, and z, and it occurs in x, y, and z occurs in all three equations, right? Pick two. What two equations do you want to work with? Why would I go with the top two? The z's cancel. Very good. So I'm going to pick these top two equations, x plus 2y plus z equals 4. And the next equation is 2x minus y minus z equals 0. If I combine those two equations together, what do you get? 3x plus y equals 4. Okay, you're going to go, well, that didn't really help me at all. I still got x's and y's. I don't know. But then you need to take the third equation. So now you got to work with another two equations. You take the one you have not used, and it does not matter which one of these top two you pick, but pick one of them to go with the bottom one. Which one would you pick? The bottom two. I would probably pick the bottom two. You don't have to, but why would I pick the bottom two? Because the z's cancel again. Now, if they did not cancel, I want to point something out. If I had this as a 2 right there and a 2 here or something, you might see, oh, the y's. It looks like the y's are going to cancel. But if you do that, you're going to get an equation that's x and z, and that's not going to help you between those two. Because the y's or the x's won't cancel. So you want to make sure that when you pick this next equation, when you pick, oh, darn. Now that's going to put my writing back that I didn't want, but I wanted to get rid of those 2's there. So when you pick your next two equations, you want to eliminate the same variable. even though it might look like something's just going to cancel between the x and y's, you want to eliminate that same variable. And this one's pretty nice because when you do it, the same variable eliminates. So 2x minus y minus z equals 0, and 2x minus 2y plus z equals 1. The z's are automatically going to drop out, and you get what equation? 4x minus 3y equals 1. So now you have two more equations. What do you notice about these two equations right here? They have the same variables. So let's move this 4x minus 3y equals 1 underneath here. Now what does that look like? Something you're familiar with? Yeah, elimination substitution. Probably the best way is to take the top one times 3, which gives you 9x plus 3y equals 12. Can I just go ahead and group that with the green one now? So you end up with 13x is equal to 13. What does x equal? 1. You're still just doing elimination substitution. You just got one more letter to work with. But you want to make sure on this first two steps here, you eliminate the same variable. I'm not done yet, though, right? Where do I got to go from there?
Yes,
You got to find y and z. Okay, I don't know. Where am I going to go with that? You could put it back up here. If you put it into a black equation, what's that going to do for you, though?
You're still gonna
Yeah, this is going to be a constant, and you're still going to have y and z. So then you could do elimination or something again. But if not, it's okay. It's okay to use one of these two equations right here. It's okay to use one of those two equations and find the other variable. So what did we say x was? 1. So if x is 1, I'm going to put it in, and you're going to get 4 times 1 minus 3y equals 1. So 4 minus 3y equals 1. Subtract 4. Negative 3y equals negative 3. So what's y equal to? 1. Now I have x. Now I have y. But I got to find z. I don't care. Where do you want to put it in? You can put it in the bottom one. So that bottom equation, the bottom equation was 2x minus 2y plus z equals 1. So x is 1. 1 times 2 is 2. Y is 1, which gives you negative 2, plus z equals 1. So what is z equal to? 1. That should make every single one of those equations true. 1 plus 2 plus 1, is that 4? Yes. 2 minus 1 minus 1, 0. 2 minus 2 plus 1 is 1. That's true. So that intersection point, you can show it as a coordinate point, three-dimensional coordinate point is 1, 1, 1 if you want. I don't care if you leave it as x equals 1, y equals 1, z equals 1.
Look at the bottom one. They both cancel right there. So it's equals 1 right there.
They don't both cancel because this gives you 2z.
I'm talking the bottom one. If you're just looking at that problem.
At this one?
2x. Oh, but it still means a. I rethought it.
Okay, so we look at this one. Whoa. Now, your book will not line up the X, Y's, and Z's. When you copy the problem down on your paper, I would make sure you lined up the X, Y's, and Z's. So now what do? Good question. Pick two equations. What two equations do you want? Or you could pick one. Let me point out, Landon might pick this one and move the 2Z over and then substitute and have to use a distributive property. I like elimination. How many like elimination over substitution? Okay, let's do, so you do whatever you want. Like I said, there's multiple ways to do this. And Landon's off and running with substitution. Landon's going to find X, and it's going to be what they call in terms of Z, because it'll be X equals negative 3 plus 2Z. So he's going to replace that right here, and that's going to give you a Z and Y, and you have a Z and a Y here. But the majority of you like elimination. Pick two. What two equations? The bottom two. If I pick the bottom two, and I want to eliminate, what would you multiply? So you have X minus 2Z equals negative 3, and you have 2Y, that's a positive 2Y if you want, minus Z equals negative 4. So what you want to eliminate is what value? Z. So I take the bottom one times negative 2. So that the top equation is X minus 2Z equals negative 3, and the bottom equation becomes negative 4Y plus 2Z equals 8. Are we okay up to that step? So what do you do from there? If you group them together, the Z's cancel, and what are you going to be left with? X minus 4Y equals positive 5. What?
Would you recommend just doing like one down the second problem there?
You can pick any two. I could have picked the top two and eliminated X. I could have picked the top and the bottom and eliminated Y. So what we found out down here is we had this equation that ended up being X minus 4Y is equal to 5. What equation did you not use? The top one. The top one is 2X plus 3Y equals negative 1. If I grouped it with a different one, I don't know, what one would you want to group that one with? If I group these two together, what are you going to cancel? The X, and you're left with a YZ. Does that help you from where you were before? No, it doesn't get you anywhere. No, there is enough information. You have just saved yourself a step with this type of problem. Because I didn't have to work with two others to get down to the same two variables. When I did elimination substitution with the bottom two, I got an equation that was already in terms of X and Y. The top one's in terms of X and Y. So what do you want to do? Eliminate the X's. I would take the top one times negative 2. So you get negative 2X plus 8Y equals negative 10. That's a good one. The X's drop out and you get 11Y equals negative 11. So what is Y equal to? Negative 1. Where do I put that? Well, you got lots of choices. You can put it in here, 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 here. If you put it in the bottom one, solve for Z. If I put it into the bottom equation to solve for Z, you get 2 times negative 1 minus Z equals negative 4. So negative 2, you're going to add 2. Yeah. Z is equal to 2. We got Y, we got Z. How are you going to find X? Substitute. Just to save me from scrolling, I'm going to substitute it in right there. If you put Z in, Z is 2, That makes this -4. What is that? 1.
The past 2 days, obviously, will take up.
Yeah, so if I was still alive, that is the X and Y.
It's substitution and elimination. And you don't have to sit there and worry about, well, why did she pick the bottom 2 equations? You don't have to. You could have picked the top 2 and eliminated X. You would have been left with Y and Z, and then you would combine that with the bottom equation. So when you do these problems, don't just sit there and erase when you don't get something somebody else got. Please don't. Let me look at it and help you, because you could have, like Wilson said, 4 pages of work. You don't want to erase it. You could have everything right, but maybe one little calculation error, or maybe the other person's wrong. Try this one.
Oh,